Just joking.
Messiness is a sign of genius.
There you go. Okay, so we have a couple spectrums of antibiotics or antimicrobials. We have broad spectrum and narrow spectrum. What would be the difference? Give me an example.
Broad is wide and narrow is
Broad treats for
Feels like a lot of stuff.
Right.
And narrow would be more like Cetra.
It's going to be very specific to a specific bacteria. Think of a shotgun versus a sniper. Okay, shotgun, you're going to hit everything that's out there right in front of you. Or a sniper, you're going to get a very specific target. Okay, that's the difference between narrow and broad spectrum. Broad spectrum is going to do the best it can to take out as much as it can, whereas a narrow spectrum is going to be very specific to a specific type of bacterium. Pretty easy to understand. And what's the difference between bacteriostatic and bactericidal?
static inhibits bacterial kills.
Does static
Cytal.
kill? Inhibits the growth. Does it really kill it? No, but it does. It's a sequential. Well, kind of it does, but over the long run, because what it'll do is it'll take the nutrients and all the different things it needs, and it'll sequester it, so it can't use it. Or you'll learn a little bit later, the flagellum, it might knock the flagellum out, so it can't move around. So it's going to decrease its mobility. So in some way, it stops it from growing, but it doesn't really kill it. Whereas bactericidal, like suicidal, okay, that term, static, you have homeostasis, static, stasis, it's just level. Bactericidal actually kills the bacteria. Sorry to say, but on 298, you're going to have to be able to recognize those 6 different types of ways in which resistance occurs. Overuse of antibiotics, the plasmids, the genetic transfer mechanisms, development of neutralizing enzymes. Those are those enzymes that we talked about, coagulase, streptokinase, hyaluronidase, things of that effect. Alters the pathway used by antibiotics, okay, or altering the cell membrane permeability. So those are the different 6 ways in which microbes become resistant to antibiotics. And then again, we talked about the agar disc diffusion. So if a bacteria, if the reports are returned, or in other words, we look at the disc and we say that disc is sensitive, that means that it will kill the microbe. If it's intermediate or resistant, the bacteria won't die. So that's what the bottom sentence on 298 is telling you. So the agar disc diffusion is that where you put all the different types of antibiotics on the one disc. And they're talking about the bacteria, not the antibiotic. Does that make sense? So the bacteria is sensitive, it's intermediate, or it's resistant. So if you have a sensitive bacteria, the bacteria is going to die. If you have a resistant bacteria, the bacteria is not going to die. Okay. Then lastly, with bacteria, we're going to talk about some bacteria that are not where they're supposed to be. We're going to talk about the upper, lower respiratory, gastrointestinal, and the nervous system. Okay. With your upper respiratory tract, where does that end? It starts in the nose and the mouth and goes how far down?
To your neck.
to your stomach, to your lungs.
Voice box.
Oh.
To your larynx, to the voice box. That's considered your upper respiratory. Okay. A little side note also, your upper respiratory has normal flora in it. From your voice box up in your throat and in your mouth and in your nose, you have normal flora. From your voice box down through the trachea, down through into your lungs, they're sterile. There is no normal flora there. Okay, so if you get a disease down there, it's much harder to get it out and to stop it than if it is in your mouth, or like a common cold, you have a sinus infection or something to that effect. It's much easier to get rid of that because you have normal flora in there fighting it as well as your immune system. Whereas once it's into your trachea and into your lungs, it's much harder to get out, much harder to fight, okay? They're usually a little more severe. So in your upper respiratory tract, you have Streptococcus pyogenes, okay? That is your strep throat. You can see pictures over there on the side where the tonsils are all inflamed, pharyngitis, okay? You need to know that upper respiratory tract is the Streptococcus pyogenes. So if I said Streptococcus pyogenes would be found causing a disease or causing an illness in where? You would say upper respiratory tract. Or I'd say in the upper respiratory tract, a main bacteria found causing problems would be the Streptococcus pyogenes. Okay. For your lower respiratory tract, where's the lower respiratory tract? Larynx to your lungs. So your trachea, your lungs, your bronchi, all that area down in there, those are your influenzas and your pneumonias. Those are a little more serious than a strep throat, right? Yeah. A little harder to combat, a little harder to fight, okay? So know your influenza and your pneumonias. You can see here also, we talked about organisms. These are capsulated organisms, okay? Your lower respiratory are capsulated organisms, which make them a little harder to fight, make them a little harder to cause a little more of a virulence, a higher pathogenicity. Okay. So know your influenzas and your pneumonias, which kind of makes sense. It's in your lungs. We always associate lungs with pneumonia, influenza. Okay. So be able to identify those. And then your gastrointestinal bacteria, your E. coli, recognize that O157H7. Do you have to memorize it? No. But if you see it, you're going to know it belongs to what? Gastrointestinal, as well as your Salmonella and your Shigella and your Staphylococcus aureus. Okay. So be able to identify where they're at and what they cause. That makes sense? And the bugs that do them, the bacteria that do them. And then the fourth one, the nervous system. So you have the upper respiratory tract, the lower respiratory tract, the gastrointestinal, and you have the nervous system. This is your meningitis. And it also has the influenza one there too in children. But meningitis is the inflammation of the meninges, which is the layers that cover the brain. Okay, so if those inflame, get swollen, causes problems. Okay, so just know that meningitis is your influenza in children and your meningitis in adults. Or you have meningitis also in infants or children too. So know the different bacterium that cause different diseases. And then your toxins-induced infections. If you look there, you got your botulism, your tetanus. They're both Clostridium. Clostridium is associated with what type of bacteria? Anyone remember? Is it aerobic, anaerobic, or microaerophil? Anaerobic. So these are toxins are anaerobic, your Clostridiums. That's why if you step on a nail, what's the big problem? Is it the rust on the nail? Bacteria introduced to where?
The blood.
Does it go into the blood? Yeah, well, I mean, it can, but that's not usually what the problem is. What happens is if you step on it, it gets about halfway in, and when you pull it out, your foot is a thick layer of what? Skin. So it's a lot of epidermis and dermis there, okay? You don't have a lot of blood flow in your epidermis. So I guess you guys won't learn. Have you learned? No, it's 7, 8. Module 8, we have to learn about the skin. Okay, so you have a layer that's called the lucidum. It's the lucidum. There's a layer called lucidum that is a light. That's where it makes our hands lighter than our dark of our skin. The palms of our feet lighter than the tops of our feet. Is that extra layer of epidermis? It makes it thicker and harder. It's called thick skin. Okay, so the palms of your hand are much thicker than here. If you stick it in here, you have much more epidermis. So what happens is the part where there's not blood supply, is there oxygen? No. Do we want oxygen? Well, does botulism or tetanus want oxygen?
No.
They thrive in non-oxygen. So if you get it stuck in the foot, the first thing you do is you close up that, put a Band-Aid on it, you close it up, there's no oxygen that can get in it. Those thrive, start to release toxins, and then you have anaphylactic shock, or excuse me, toxic shock syndrome. You also have botulism, which is a very sick illness, and you have tetanus. You can see in that picture that tetanus paralyzes the muscles, makes every muscle in your body contract. That's what tetanus does to you, okay? It attacks the muscle system, or your muscles. Does your stomach or do your back have stronger muscles?
Your back.
Your back does. So when that's why when they all flex at the same time, they get that arching, because these flex, these can't compensate for it. You get the arching. You either snap your back or you paralyze your diaphragm and suffocate to death. That's how you die from tetanus if you don't get a booster. It used to be really bad with sailors and in old times before they had your Tdaps, your antibiotics for them. Okay.
If it gets to this point, it's pretty much too late.
Yeah, it's pretty hard then. If you get to the point where every muscle in your body is contracting, you're pretty well
Pretty much dead.
gone. Yeah, because they can't keep you breathing long enough to get the antibiotics in there to get it out there, because all your muscles are all contracted. You can't press down on the lungs. You can't press to keep them, filling and emptying. So you suffocate to death. Pretty much what you do. If your back doesn't snap first, get you that way.
Does it
But-
happen pretty quickly?
No, it's not. It's not going to happen. Once it starts to happen, it's going to spread pretty quickly. But it doesn't happen. I mean, it's not like you can step on a nail and 6 hours later, there is. I don't know what the gestation or the generation time is on it, but it's not. It's not like you need to go quickly and get the Tdap. You don't have your booster already done, but a couple of days, maybe a week or two before you really start to see the effects of it.